Hello, my name is Robert Sego, and this is a demonstration of network amnesia, reducing catastrophic forgetting caused by stochastic gradient descent. You'll need to, before you start working with this code base, do two things. You'll need to first get the relevant data sets. Fashion MNIST is already part of the PyTorch module, so you don't need to worry about that, but you will need to download the VOC 2005 dataset available at this website, linked in the README. Get the tar, extract it, and put it in one of these two folders, or put it in VOC 2005_1 or _2, depending on the train or the test dataset, respectively. You should only have the .pys, .txts, requirements.txt, and the .md in your code base here. The rest of this is produced by the training files, such as train_sgd.py. Now, as after you've activated or installed and activated your environment here using pip, you're running train_sgd. Up here are the parameters that you can change that I manipulated for my experiments. While you can change the input and the batch size, as in the ratio 32 by 32 pixels with 16 batches, that is generally not what I was manipulating for my experiments. I was trying to keep that constant. What you're actually doing, other than selecting what the base name for what you're going to save, is changing which dataset we're working with and which model. The datasets are in dataset.py. They're specially modified for a progressive learning format. There's the Fashion and the VOC 2005, and then there's the models, a convolutional net and a fully connected network. Both of them displayed there. Now, once you've trained this up, it's going to take a while, which is why I have some pre-trained models over here. We're going to grab the Fashion CNN, actually. Let me change that there just for consistency, but it's not relevant because now we're going to hop over to progressivelearning.py. We have a base model that we have already trained. It's called unog fash CNN. It was the Fashion MNIST dataset on a CNN. It's not been changed. You're going to want to set these to specify what, yes, it's pulling in the model, but it needs to know what to add to the model, which is why you still have to set these. Now you set model save base name, and you're going to decide whether you want to use transfer learning or not use transfer learning for this iteration. And you can do one after the other, which is why I will generally have output models that say trans, no trans for transfer. Now, once you've done that, again, you can mess with the learning rate in both these files, but I keep it constant at 5 times 10 to the negative second, since that's generally pretty consistent. Both these files are going to just Python 3 once you have your environment set up, and then just the file name. But this will pull in the existing unaugmented Fashion CNN, and what it's going to do is it's going to tack on an additional class to the output of the model, and then it's going to train only on that additional class. You can see here, if you set the dataset to Fashion, it's going to pull in the 5th class. In train_sgd, it pulled in the first 5. Sorry, it's going to pull in the 6th class before it was training on the first 5. Once it's done that, and it does it very quickly, you can jump over to test.py. Test.py, you just give it the name of the .pt you want to test. We saved it as testprog, so let's grab test progressive learning. There we go. Python 3, test.py. And it will just outright put the accuracies on each of the classes that were relevant right here in the terminal. Give that a second to run. Now, generally what I'm changing in my experiments here are these, which data set and the classes themselves that I want to load in. As you can see, the model, this progressively learned model, is 100% accurate on sandals and nearly 0% accurate on everything else, for an overall accuracy on the test set of 16%. If we were to repeat the test on the unaugmented model, let's grab that name. Remember to set the augmented to false here if you're working with an unaugmented model. And there you go. It's accurate on almost all of the 5 initial all 5 initial classes. Okay, thank you, and that's how you use this data set. If you want to, you can also run plothistory.py here with the history path to get some output graphs of how your loss decreased over time. But thank you very much, and happy testing.